Hang on a second. Oh, yeah, you can start rolling. Okay. All good? All right.
I don't know
Chose
where to
the wrong day to dress down.
Yeah,
Yeah.
that's why we're outside.
Yeah, that's true. Right. All right. So we're just getting set up. Hey, everybody.
Bye, Tara.
See you, Tara. We're doing a new thing on the roof, as you can see. So all right, let's jump into it.
All right.
Hi, everybody. Welcome to another episode of the Production Geeks.
Get ready, it's Production Geeks time. Let's dive in.
Thanks again for joining us on another episode 3 of the Production Geeks.
Yes, 3. It's been a couple of weeks.
It has. So we're here on our lovely New York City, Midtown Manhattan rooftop located just off Madison Avenue, where behind us you could see the beautiful Empire State Building and all of the beauty that Midtown New York has to offer this time of year. I mean, how awesome is this?
So yeah, you're looking right over to the buildings of Times Square. You get the Empire State Building. You can see over the East River. It's thinking about July 4th coming up, and if we're working on this project, we're going to be talking about it in a few minutes ago.
Yeah, it's going to be perfect.
I'm up here watching some fireworks and having a good time.
Nothing beats it. So what do we have today?
We're doing some little margaritas with some Patron.
Cheers. Skinny margaritas.
Yeah, Mike's not drinking this month.
Yeah, there you
he's
go.
cheating on this.
Nothing sets the tone better. So today we want to take a dive into a couple of projects that we're working on, sort of pun intended mid-flight. The first is coming up on the 4th of July. It's a massive international celebration here in New York City for the 250th birthday of the country, and it will involve tall ships from all over the world, and we are being tasked with live streaming it for multiple days. And we're going to have a great setup in our studio with a field team. And then the next project we're going to talk about is pretty remarkable. Why don't you kind of give us the elevator pitch on that one?
So we're working with a company. We'll wait until after the event to name the company, but they're going to be doing the first fully electric passenger plane test flight up in Plattsburgh in a couple of weeks. And we were tasked with figuring out a way to live stream that, both with cameras on the plane and cameras on the ground and a whole bunch of stuff. And it's been a fun project, and hoping that everything goes as planned. But since the first flight, you never know what's going to happen when that thing takes off.
I mean, it's all engineering, everything. And the subject matter is how have they engineered it and how do we engineer around it? So we'll talk about that next. So the first thing we want to talk about is our 4th of July project. So walk us through the, what's the 10,000 foot view of our setup, the studio, field,
So as Mike mentioned, we're going to be live streaming the Sail Forth, which is all the tall ships coming into New York Harbor, Brooklyn, Staten Island, and everything. I think they're all coming from New Orleans right now, so it's a big trip. And
the ships are coming from all over the world.
So this is actually through the company Sail Forth, and the State Department wants to really showcase how the American people are interacting with the tall ships coming from these other countries. So as part of that, they want to do some long live streams, let people that are watching it learn about the different ships, where they're from, why they're important, why we should care, get people's reactions going on to them, and really just kind of promoting that as a tourism and kind of a nice friendly place for people to come, and people will be interested in what's going on.
One of the things that we wanted to use as inspiration for this project when we were bidding on it and pitching was the Artemis broadcasts, which were multi-day live streams around the Artemis flight around the moon in the earlier part of this year. And their setup was pretty straightforward. They would have sort of an anchor at a desk in that control room, and then they would go off into field reporters, bring expert guests on, and then they would roll in a lot of videotape packages, video pieces that were pre-recorded. And so we're kind of using that as inspiration. And so we're going to have a studio set up with a remarkable host who is a multi-time Emmy award-winning broadcaster who has done the America's Cup races for NBC and among others, and plus is a remarkable sailor himself. But so what are we looking at in the studio?
So we're making a nice investment to upgrade to a brand new LED wall. Working with a company over in New Jersey to supply it. Somehow we're getting a nice 1.2 pitch, which is
amazing,
absolutely insane.
Well, let's talk about that. The pitch on these screens really matters. On video, when you're in a studio, what's kind of the max pitch?
I mean, I would say 1.9 would probably be as high as you would want to go.
And when we say these numbers, are we talking millimeters? And is that the distance between the pixels?
Basically the pixel, yeah, the pixel distance, the size of them. But the bigger it is, the more space you have between. So as you zoom in, you can get more issues. You'll start to actually see the LEDs rather than a nice flat image. So the smaller you go, the finer the pitch, the smaller the pitch, the closer they are together, the less you're going to see them. Now, being in Midtown Manhattan, we don't have a giant studio. It's decent for the size for this area, but if we want to be further away from the wall, we can only go so many feet and still have room to put a camera and all that. So the smaller pitch allows us to be closer to the wall rather than.
So when we're setting these things up, what are the key things we need to consider when we're looking for an LED wall? It's obviously the pitch, it's the quality.
The pitch,
I mean, Dave, you've overseen the installation of many LED walls at this point.
A lot of it is, I mean, you gotta find out what the use is. If it's just going to be in a Times Square billboard, you don't need a small pitch because nobody's going to be that close to it. But and you don't care about shooting it on a camera, you don't care about any of that. But the biggest thing is looking at the refresh rate. A slow refresh rate, you can start to get the scan lines through it. You got to make sure that it can have a higher refresh rate than a standard one. The pixel pitch, which we mentioned, but also the distance. The further away you are, the less you're going to be able. The subject is. It'll throw it slightly out of focus. Any of that stuff will go away.
Now, when you're installing something like this, one thing we're working now is twofold. One is, how the hell do we mount this thing? It's heavy. Mm-hmm. And number two is, how do we power it? So tell me about both of those things.
Obviously, these things, I mean, they're LEDs. You don't think LEDs draw a amount of power, but when you have thousands of the little LEDs on panels, it adds up really quick. So, I mean, each panel at a full load takes over an amp. So you're looking at around 70 panels, 75 panels. You're looking at a high pull if you're running at 100%. The nice thing is, inside, you're never going to run these walls at 100%. You're going to be going at 7, 10% maybe, especially so you don't have to go crazy with lights to offset it. So we don't need that much, but you never know when that PA is going to come in. You're going to tell them, oh, just bring up the wall a little, and they're going to bring it to 100, and then you're popping all your circuits.
When we installed the two walls at Box Inc.'s headquarters, it was 14-foot wide?
Like 14.5 by 8, give or take.
Yeah.
So pretty much close to a 16:10 ratio on those. And they wanted, it was a 1.9, and they spec'd out per 5 panels or 6 panels on each row, 120 amp circuit. So that was definitely way overkill, but I mean, that was done. And I mean, you got to bring in the commercial electricians. And I mean, when you're looking at pricing, you got to factor in all those little things because you're not going to be able to run it off your standard power.
And then installation. Now, a lot of these kits, do they come with supports, or is it generally you're buying the panels themselves and then the supports and the processor are separate?
There's different companies. I mean, you get kind of the general ones that a lot of them are basically they have a U.S. headquarters, but they're based out of China. They're your kind of low tier packages. They sell a lot to churches and places that don't necessarily want to spend the higher numbers to get
willing to roll the dice a little bit.
And also they have a lot less, they're not doing broadcasts, they're not and all that. A lot of times you can either negotiate with them or they'll toss in the support kit or the mounting rails if you're going to fly it. But you still need, if you're going to fly it, you still need the trussing. You need somebody that knows how to rig it and hang it. The ground supports are great, but when you're in a small studio like ours, now you're losing 4 feet because you got to have that back supported and weighted down so it doesn't tip forward. So that's why we're looking to do kind of a semi-permanent installation and do a couple of fake walls and actually do a wall mount.
Mm-hmm.
Now, when you're looking into that, only certain ones can be wall mounted because if it's front, it has to be front serviceable. So there's a problem. It's mounted to a wall, you can't get into the back.
Mm-hmm.
So you got to find panels that are front that you can actually take the panels off in the front, service them, swap out a module if you have a dead pixel, whatever it could be. If you're having a power issue, you can service it from there. You don't have to unscrew all these things to fix anything.
So, when we talk about the angle that we're going to install our walls, we decided to do a slightly larger than 90-degree angle. And what's the reasoning behind that?
So, I mean, a lot of the stuff now, you can get the curve panels, which is you're going to have a nice seamless kind of one. Again, it goes to the space.
Right.
To a nice smooth 90-degree curve, you need a couple of feet of that curve.
But they come at a premium price, right?
Again, it goes by the vendor again and the quality that you're going to get for good quality. Yes, very premium price. Now, what we're doing is if you do a 90-degree angle, they're going to come together like this.
Mm-hmm.
You're never going to get a clean seam between it. So, well, it would be nice if you could and just butt them right up against each other. You're always going to have that black line. There's going to be an edge. So by opening it up just slightly, you're able to cheat one of them behind. You might lose 1 or 2 lines, which nobody will ever see.
Mm-hmm.
But you can kind of slide that second wall just at that angle behind it. Hi, Raul.
Raul, you got to come over here and say hi.
Come on over.
Just come on over here and wave. Wave to the camera.
So, Raul, we're talking about putting in that video wall.
Yeah, so Raul's our super.
Yeah, he's the super of the building. And
Raul, when somebody like us wants to mess with your space, what do we need to consider? Insurance, right?
Yes.
So, so Raul's here to make sure that we're enforced and we have a clear insurance policy.
You guys are great. Don't worry about it.
So all right. So the angle, also the viewing angle of the pixels matters with the camera, or no?
Most of them have a very wide viewing angle. You should be able to get at least 180 or 170 degrees. But if you have one camera way off, you might be clipping something. So opening it up gives you a little bit more room to play.
When we think about these screens, sometimes I think a lot of people say, well, how good are the seams between the panels, like the individual, because you've got the panels, which are the actual consoles, right? Yeah. Which may have 8 sort of LCD units.
It depends on them. Yeah, they have basically what they call modules inside. Most of them run 6 to 8, 12 modules.
And do they always line up well, or if they don't, can you fix them? Like, are they?
Yeah, I mean, they can be fixed. So, going back to a previous event we did for another client over at the New York Historical Museum, the scenic company mapped everything out. Everything was measured to the millimeter. It was going to look great. We saw all the plans. They came in, they spiked the floor. We installed the wall, and they come back to us, and they're like, it's not in the right place. So there's a stage box, and they measured that as the middle of the stage instead of actually measuring the middle of the stage. So we had to take the entire wall, at least the first 4 layers of the wall, the top layers, to be able to slide it over exactly where it had to go. Now, you got some of these production techs that just spent a couple hours putting a wall up, and now they're going to take it down and put it back up again. They get a little frustrated. So you can definitely see when they're not aligned right. The modules are usually easier to fix within it. Otherwise, you got to unlock them and kind of just jiggle them into shape and do that. So that, because they rushed it, it definitely did not look right. But so we had to spend a couple hours kind of fixing everything and aligning it. But when it looks aligned, I mean, it looks very seamless. You can't really tell. I mean, if it's all black, you're going to see little seams and little edges. But once you throw some color on there, it looks really nice.
So beyond this one production, now in this particular case, we'll be able to put a nice, beautiful wide shot of New York Harbor. Hopefully the weather will cooperate on the 4th of July and following days. But, we can do virtual sets after that. I mean, there's
virtual sets. I mean, we're right on the roof. I'd love to get an IP-based camera that we can run right up here, and we could pump in a shot of this roof behind everybody with the Empire State Building. I mean, that would be, we can put anything we want in there.
So this is just one, it's just one part of that big project, but really exciting, something we've been talking about for a long time, and things are coming together. Oh, and the other thing we have to think about is mounting it, right? So we're putting up false walls.
Yeah.
So which essentially we're using, 3/4 inch plywood with 2x4s that are, the highest construction grade because it's a lot of weight.
It's a lot of weight.
Bolted to the floor, secured to the wall and ceiling.
Yep.
All right, so that's exciting. That's what we also simultaneously we're working on this really amazing project.
Yeah, we mentioned it. We're going to be live streaming the first fully electric passenger plane, 30-person passenger plane, test flight.
And it's just the pilot that's going to be in there, right?
Just the pilot. Was up there last week. We were testing all the data connections, programming the live view servers. They work on their network.
So before we talk about the solution, what was the problem? They gave us a certain amount of weight and space, right?
So, yeah. So basically, they said, "Can you stream this?" And we're like, "Yeah." I mean, we can
stream anything.
we'll figure it out. But then they go, "You only have X amount of weight. You can't really run cables because then everything's meant to be run in the wing and then pulled out." I mean, this is a fully engineered plane that it's literally mapped out to the kilogram or the whatever, however you want to, whatever weight.
Yeah.
And so we were trying to figure out different solutions, and we were going through all different things. Like if we run this cable, use this camera into this unit, and it just, everything was adding too much weight. So we discussed using the LU Smart app from LiveView, which does, unlike the actual field units, it does a live and store. So we're able to stream and also record into the phone. So it's going to be a short 10, 15-minute max record time. So luckily, once these things are mounted, we don't have to worry too much about battery, anything like that, but we can start them all up, make sure everything's streaming, and we have the 2 servers sitting in the fly pack that we built.
Yeah, so before we get to that part, so the live view, we've talked about this in previous episodes. AviWest High Vision now makes a similar product where it takes the cellular and the Wi-Fi, combines it. So now we've got the cellular and the phone, but we're also installing Starlink on the plane.
Yep.
Right?
So there's Starlink installed on the plane. So we're going to be testing the connection between the phones and the Starlink during a high-speed taxi test next week, making sure the phones still talk. But that's another thing with these being on a plane. The way the Starlink works is it connects to different satellites as you're moving. Now you're now adding that speed of the plane. So what we actually have to do is put in the delay units, which we were talking into this, because so live view, you're able to delay the amount of time, which will allow it to buffer. So if you have a little blip, it'll be fixed before that actually hits your system. But now we're putting in a 2 or 3 second delay from where the live view comes from the plane till it hits our control room. Now, how do you do everything with the local cameras that don't have that?
So we've got how many cameras on the plane?
We're running 6, 5 will be streamed.
Okay, so those are all iPhones with the LU
iPhones.
Smart app.
Yep.
And then we have how many physical
there's going to be about
operated
7 cameras. Only I think 3 or 4 will be on the stream, and then we're going to have a live view phone unit in flight control, just like the flight control room, and then we're going to be bringing in via Zoom a watch party out in LA.
So the cameras that are operated, that are connected, that are not phones, they're going to use a live view pack, live view.
No, so those are going to come directly into our system.
And so those are coming through an SDI feed.
SDI. So we had to put in we put it in Everts delay system.
Because the challenge is we're delaying some cameras. They're not everything's in sync, right?
Yeah, and there's no way to sync all that up.
Mm-hmm.
So we're put in a delay system, so we're able to delay all those incoming signals. And on the ground, when we're doing our tests, we'll actually be able to make sure that everything is coming in sync. Now, we also had to do this with audio. So most of the cameras that are going to be coming in through SDI, they're either coming in through the GGI SDR wireless kits, or it's going to be coming from a drone. I can't feed the audio through the camera. So we're actually doing a SDI embedder, bringing it in, which goes into the delay unit. So we have our audio mixer, which will feed out into this embedder.
And this delay unit, you're able to program how long of a delay you want for each camera. Is there a maximum?
It depends on the frame rate that we're doing. We're running, I think we're doing 1080p 2997. Should give us up to, I want to say, about 3.5 to 4 seconds. We're going to try and go at 2 as long as it's stable for everything, which gives us that headroom on it if we have to delay it more. And then the audio will go through the same process of doing that. Everything's coming into the ATEM constellation to switch. And then we're going to feed that into a vMix system. And we're going to be taking real-time flight data coming in. We work to do an API with the flight data team, and they're going to be pushing all that live data to us. We're going to pull it into Singular Live, which is an HTML5 graphics program, which basically will create a web page that we can overlay. So we'll do that as kind of a downstream overlay, so people will be able to see the speed, the distance, time.
How did you connect the data to the Singular Live?
That's a good question. That was I got to go back and actually I don't have the answer to that right now. But we basically it's a push and pull JSON file. So it's basically there's triggers that are just the Singular Live is looking to pull that data every whatever milliseconds or seconds or whatever we tell it to update. And on the back end, the flight data team is pushing that data every few seconds, so then it'll just marry itself together.
We're using like a Google Sheet or something in the middle, or
no? So it's literally going to be pulling from the flight data.
Wow,
like things that they're pulling that.
So we can have real time data displayed on the screen.
Yeah, that'll be the real time.
So vMix is just performing one small task, which is the overlay.
Yeah, the overlay, and then we will either probably stream out of that into a live view solo, which will then hit the different locations that we have to go to.
Why did we choose the solo over the 300 for this particular output?
300s they're very, very good at getting signal from point A in the field back to a server. The actual RTMP streaming from those directly leaves a little bit to be desired right now. The live view, the solo unit, I mean, that's really what it's meant for.
Yeah.
We're also considering, we'll do this during the taxi test once we get all, because we're in the middle of Plattsburgh, New York, in the middle of an airport. So we're going to have Starlink data from the ground and all that. So once we have everything tested and we figure out latency and all that or any potential issues, we may also run it through the LiveView Studio, which is a cloud-based app, which basically the solo will push to that. And then what we can do is pull in a backup iPhone with just a bump shot of the airport.
Sort of like an oh shit.
Kind of if anything goes wrong, we're still pushing something to the cloud, and the stream won't go down.
That's the thing, is like a stream blips for like a second. Some of these platforms freak out.
Yeah.
So
Exactly.
so you want to just always have something.
Always have something there where we know that stream's coming from the cloud. If Starlink were to go down, we're going to have generators, but we still don't have a transfer switch. It's still going to be that blip in the middle before we have to plug something in, or if something reboots, or if something fails. I mean, it's
so you have the high speed test coming up.
Yeah.
And the next, what are you most looking forward to testing at that high speed test?
Not to be kind of like pretentious, but like I'm very confident in the engineering setup of our entire fly pack and our workflow. That we've tested, we've run through everything. I mean, we'll still do it again to make sure there's no other changes or tweaks that we have to make. But my main concern is just making sure that the data is getting to the cloud.
Yeah.
Once it hits that cloud and we're connected, we know we're getting data into the live views. But when that plane's moving at 200-300 miles an hour, whatever it's going to move at, and you're trying to pick up different satellites, and once it gets up in the cellular service is not great where we are anyway, in the middle of an airport, in the middle of upstate New York. So you can't rely on the cellular. And that Starlink needs to hit the satellites. And when you get moving at that speed, I know they use it on planes and all that, but I don't know what units they use. They don't tell you that.
Speaking of Starlink, that was a whole nother thing we needed to work out was port forwarding from the Starlink through a router into the live view, because networking becomes a whole thing in addition to video engineering, right?
Yeah, so I mean, it's not my favorite thing to do, networking at all, but it is part of the job now. I mean, everything's becoming IP based. I can hook up the cables and we get our little live view screensaver as long as the software's up to date. And we know we're getting signal from our system, everything into our system. But you go live, you see some color bars pop up on the live view. You know you're talking to the server, but you're not getting any video in the middle of it. So what's actually happens is a lot of networks and a lot of network providers, they block a lot of this incoming video in these ports for firewall restrictions and all that. So we had to open up port forwarding, and as soon as your IP goes down, changes, when we hook up an IP to our server here into our network, it has to be one system. We got to change it up there. So it was an adventure. It took a couple hours to get everything working, but that was kind of the main point of the visit last week.
Dave was just like sitting, like trying to get out the door so he could drive the stuff upstate. Well, I'm feeling raindrops.
Yeah.
And so I suppose we should call it a wrap on another episode.
I think so, but I'm looking forward to our next one when we can recap both these events. And
also upcoming, I want to talk about some of the software in the coding that you've been doing, because I think that's a really amazing thing that Dave's been building. Some amazing software solutions to solve some of our problems. So much more. Thanks for tuning in. Remember to like and subscribe, and also follow us on whatever platform you have. If you're on Apple and Spotify now, we are one of the few early adopters of the video. So we've just been accepted, by the way.
Awesome.
So you can enable video on the Apple Podcast or Spotify to watch this if you haven't already. So thanks for watching. This is